everyone again. Today we will talk about the test for divergence. Okay, as usual. Okay, so as usual, let's do some background knowledge. Okay, before we talk test for divergence, we need to know what does this test for divergence says. Okay, so this is the background knowledge. Okay, if the limit of the limit of a sequence a sub n does not exist. If does not exist, the limit as n approaches to infinity of a sub n does not exist. If does not exist, or the second option is if if the limit of a sub n as n approaches to infinity is different from 0. If it doesn't exist, or if it is different, if it exists but it is different from 0, then then the sequence the sequence, I mean the series, we are talking about series now, the series um diverges. Diverges, the series diverges. Diverges. This is the key idea now. So all we have to do is, if the limit of a sub n as n approaches to infinity does not exist, right? Or if the limit of a sub n is different from 0, then the series diverges. So we will have a series, and then if the limit of that sequence does not exist, or if it is different from 0, simply we call it is diverging, or it's divergent. So if it is equal to 0, we don't know nothing about that. We will talk about that in another video. Just all we have to focus on this one is for divergence, test for divergence. Our main concern is if it doesn't exist, or if it is different from 0, it's diverging. It's diverging. When it is equal to 0, that's another story. It may diverge or converge. We will talk about that one in another video. Now let's see this example. Let's this example now. Number one. Number one, practice on this one. Let's say if the question says like this: show, show if, if the series, n square over 4n square plus 2 diverges. We're gonna diverges. So to show if this diverges means that we have to meet these criteria, the criteria mentioned above. So don't forget that. Now let's do the limit of, or let's write the limit of the limit expression of the sequence. That means the limit as n approaches to infinity of n square over 4n square plus 2. So we know this one from limit of a sequence, how to find the limit of a sequence. So we apply that one. Then we're gonna decide about this series. So this is gonna be the limit, the limit as n approaches to infinity of n square, because look, the denominator has n square, so we have to divide everything by n square. So that means n square, that's how we find the limit, over 4n square plus 2 over n square, right? Over n square. Now my target is what? To find the limit, and then based on that limit, if I find the limit which is different from 0, it diverges. Again, if it is if it doesn't exist, again it diverges. So that's what I'm looking for. So this is gonna be this, the limit. All right, what is n square over n square? N square over n square is gonna be just 1, right? As n approaches to infinity, of course, over, all right? What is 4n square over n square? N square will cancel by n square, that's gonna be just 4, plus what is 2 over n square? That is 2 over n square, right? Now this is time to plug in my infinity. This in turn will give me, if I plug in infinity, this is gonna be 1 obviously over 4 plus what is 2 over n squared? Means if I plug in infinity, 2 over infinity square is just 0 because 2 over huge number is 0. This is going to be 0. So this will give me 1 over 4 plus 0 is simply 1 over 4. Okay, 1 over 4. Look now. The limit is different from 0 because 1 over 4 is not equal to 0. Since the limit is different from 0, by the second condition here, if the limit of a sub n is different from 0, then the series diverges. Therefore, from this I can conclude, hence, since the limit of the sequence is different from 0, hence my series a sub n, what happened? Converges, I mean diverges, okay? Diverges, okay? Diverges. Okay, so this over here, this series diverges because it's the limit of the sequence is different from 0. Okay, the limit of the sequence is different from 0. All right, now let's do second example. Let's do second example. Okay, let's do the second example. Number 2. All right, again, remember. So let's say this is the series 3 plus n over 1 minus 3n. Remember, this one is the series, okay? What happened to this series? Okay, we're gonna see if this diverges or converges. This is diverge or converge. What will happen to this, okay? So for test for the divergence tells me that I have to find the limit of the sequence, okay? The limit of the sequence. So I have to write this one in limit expression form as limit, the limit of 3 plus n over 1 minus 3n as n approaches to infinity is equal to what? Okay, is equal to what? So as always, again, look, in the denominator, I have 1n and the power of 1. That's the maximum exponent I can have now. So this is going to be the limit, all right, the limit of what? 3 plus n divided by just 1n because I have just n in here, all right, over 1 minus 3n over n, okay, over n, okay. So what will happen this, all right, as n, in fact, approach to infinity, okay, approach to infinity. Now keep going. So this is going to be simply, I can expand this into different forms to make it clear. The infinity is equal to, okay, 3 over n plus n over n. I can rewrite it this way if I want to, okay? 1 over n minus 3n over n, okay? So as n approaches infinity, now this will give me, again, 3 over n plus just 1, right? N over n is 1, over again 1 over n, right? And then this is minus 3, okay? Minus 3. So this is in fact the limit, okay? The limit, I don't have to forget this, as n approaches to infinity. All right, this will give me what? All right, so 3 over infinity is just 0. All right, 3 over infinity is just 0 because this 3 over infinity is 0. I'm now substituting my n with infinity. So this is going to be plus just 1. All right, I have 1. And then over, right, 1 over n is 0. Okay, 1 over infinity is 0 because I'm plugging now infinity at this time. So minus 3. Okay, this will give me that this is 1 over negative 3, which is equal to negative 1 over 3. Okay, so negative 1 over 3 is different from 0. Okay, different from 0. So look, our rule says that if the limit is different from 0 or if it doesn't exist, well, the series diverges. So hence, okay, hence, the series 3 plus n over 1 minus 3 n diverges, okay, diverges, okay, because the limit of a sub n as n approaches to infinity is different from 0. Okay, it's different from 0, which is the negative 1 over 3. Okay, so that's how you use the test for divergence, all you have to focus is on these two things. All right, the rules here. If the limit of the series, I mean sequence, doesn't exist, or if the limit of the sequence is different from 0, then the series diverges. Okay, the series diverges. So that's all about test for divergence for today. I hope you enjoyed this video about test for divergence. Next time I will show you some other important concepts, and I'll see you another time. Have a great time.